Hello, in this lesson, I'm going to want you to solve equations involving more than one operation and solve equations involving consecutive integers. Some vocabulary words you're going to come across are multi-step equations, consecutive integers, and number theory. If we take a look at example one you are expected to know how to do already, but I'm going to review it for you in case you forgot. When we solve an equation, you will always want to use inverse operations in the opposite order. So we're going to undo addition and subtraction first. So on this problem, I am subtracting 4 from x, so I'm going to add 4 to both sides. So bring down the 11x. Notice negative 4 plus 4, well, that's 0, isn't it? So I don't have, that just cancels out. 29 plus 4 is 33. Now, 11 times x. If there's no symbol between the number and a letter, it means multiplication. So the opposite of multiplying, in this case, we're going to divide both sides by 11. And x equals 3. You can check that by replacing x with 3. If I take 11 times 3, I get 33 minus 4 gives me 29. Let's take a look at a problem with a fraction in it. For some reason, this seems to be confusing once in a while. You look at this bar, and this bar means divide. So what I'm going to do is I'm going to multiply both sides by 8. If you want to write it as 8 over 1, that's fine with me. Now, make sure you do the division first. I want you to reduce the 8s. Because if you just multiply 8 times 8 plus 7 and you don't reduce 8, you haven't made the problem any simpler. You've made it actually more complex. And we want to make it simpler. So then we get a plus 7 on the left side. On the right side, 5 times 8 is 40. Now, we're going to undo adding 7. So I'm going to subtract 7 from both sides. And we get a equals 33. And there's your answer. Let's take a look at an application problem here. It says Susan had a $10 coupon for the purchase of any item. She bought a coat that was half off its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? Write an equation for the problem, then solve it. So I want you to write the equation. Don't just give me the answer. I got to see the equation on this one. And when you're doing a word problem or an application problem like this, always define your variable. I call them let statements. Let, in this case, I'm going to let x equal the original price of the coat. Now I'm going to write my equation from there. So I know I'm taking $10 off, but I'm doing that secondly. That's after we paid half off for the coat. So I'm going to take half of the original price. So I'm going to say 1/2 x. Then we'll take the $10 off, so minus 10. That equals to the price of the coat, which is $125. So now we're going to use our inverse operations to solve for x. The opposite of subtracting is adding, so I'm going to add 10 to both sides. So bring down the 1/2 x. Negative 10 plus 10, well, that's 0. 125 plus 10 is 135. Now the bar means divide, so I'm dividing by 2. The inverse operation of dividing is let's multiply both sides by 2. And once again, make sure you do the reducing first. Reduce the 2's first. So you get x equals, if I take 135 times 2, we get $270. And since it's a word problem, make sure you have your units. So $270. There's my answer, 270. Now we're going to look at some number theory problems. Number theory is exactly what it sounds like. We're looking at the relationship of numbers, how they're related, and maybe write some expressions for them. I gave you 3 things we're going to model number theory with. First off, consecutive integers are numbers that come in a row, like -2, -1, 0, 1, and 2. Notice they're 1 apart. So what I'll do is I'll let the first number be n. The second number, I'm going to add 1 more to that. The third number, 1 more to that, and so on. So n, n plus 1, n plus 2, n plus 3, n plus 4, and so on. Consecutive even integers would be like -2, 0, 2, 4, 6, 8, 10, so on. Notice they're 2 apart. So when I represent them in symbols, I'm going to use n, n plus 2, and n plus 4. Here's one that is kind of confusing. Consecutive odd integers, like -1, 1, 3, 5, 7. I don't know whether it's a negative sign on this chart. That's supposed to be a positive 3. So notice they're 2 apart also. So we use the same thing. The only difference is between even and odd. Your first number and even number is going to be even, or the first number here is going to be an odd number.